Hey everyone, welcome to this video. In this tutorial, we aim to simulate laser beam welding in Sysweld. So let's jump right to it. So as always, we start with visual mesh. I click on new file and here it should be on ZX. By holding S, I can move this one. So from node by XYZ locate, we can create our nodes. So this is 0, 0, the first one. Next one should be 1.5, 0, 70, 1.5, 70, 0, 33, 0, 33, 1.5, 37, 1.5, 37, and 0. That's done. Now from 2D 3/4 point mesh, we select our points, this one, and this one. By scroll button we can select it. Okay, I want to put the value of 3 for this edge and this edge, and this one should be 14. It needs to be biased, so linear bias edge, and this edge, and we want to flip this one. So by clicking on scroll button, we see that the mesh is created. Now we want to select this side, which is the same, so 14, 14, and this is 3, so this is too tiny to be selected, yeah, and here it needs to be 3 as well, and want to bias the edge, this one and this one, and this one needs to be flipped. Create mesh and OK. Now it's time to create the weld. Okay, 4 points, this point, scroll button, this one needs to be 8, so let's see how it goes. 8 and done. Yep, this is a good mesh, fairly acceptable, and it's time to sweep it by here, 3D sweep, and this should be vector, standard axis, and we want to sweep it along y-axis. And okay, the distance should be 70. We have to select the faces. Here I click this one, and by holding A or the scroll button we can rotate it to see in which axis is rotated. So by selecting this one, number of 48 is okay, we mesh it and click OK. So this is done, and we want to select the other surface. Click on this one, we select the element faces here, everything else is the same. Select this one, y-axis, OK, and mesh. So as you see here is created, 48, mesh, and OK. Now last but not least, the weld. So we're selecting this one, and OK, then mesh. But keep in mind this number should be the same as the base metal part, so it is 48. Mesh and OK. As you see here, our part is created. So I select the flat wireframe. Here I put it on isometric view. Now it's time to check the model. So from check, coincident nodes, we click on check and we see there are a bunch of nodes. Coinciding, I select coincide all, fuse all, then apply. Check it again and we see there's no any. Okay, now it's time to create clamping conditions. Here I would put it on node. I select this one and this one. Right click, tools, add to new collector, and this collector should be U, X, and Z. Okay, click on the screen to reset that. Now I want to select this one and this one. Tools, add to new character. This character means to be UZ and OK. Now by holding the scroll button, we can rotate the model. Click on the screen. I want to select this one and this one and add a new character. This one should be U of X, Y, Z. Now it's done. The last thing we should do in the visual mesh is to go from 2D, extract from 3D mesh. We select element faces and open faces. So from here, I extract 2D and apply. So here in the part, we see that this one is the thing we wanted. So we name it heat and OK. It's better to rename them. This is Weld. This is base metal left, and this is base metal right. So we save our model. Here we can say save. The name, laser beam welding, and this one meant to be laser. Now let's go to the visual weld. We open the file, laser beam welding, laser VDB, and we want to go to the welding trajectory. Here from 2 nodes we can select it. So here we have 9 nodes, 1, 2, 3, 4 and 5. So this one should be it, and this one must be the reference, and we want to rotate it. Here 1, 2, 3, 4, 5, and this one is the reference. Scroll button. Now we see the weld path and the reference created. Scroll button again. Now let's go to the welding advisor. So I name it laser, and we select the working directory. It should be solid, and the components we can select them by holding shift. We don't need to select joints with filler, and the material must be Inconel 625, and as we see, everything is assigned here. Now we can go to the next part. So we select the weld line here, filler material, welding group should be weld, and here the weld pool, and it's better to select the laser here, and the velocity is 5, the initial time is 0, and it can calculate the end time itself. Here it says top diameter and bottom diameter. If we click on this one, we see that there's something here says the top diameter and bottom diameter, and this one is the penetration. In this one we don't have the gold dot model, but we have the Gaussian distribution. So this defines the Gaussian distribution parameters, and this one should be 2, the bottom diameter is 1, and the penetration is 1.5, as we want to have a full penetration. And the energy must be 130 watts, and as you see, watt is joule per second. So if we divide the 130 watts by 5, which is the velocity, millimeter per second, we would have 26, which is joule per millimeter. This is how we calculate the energy. Okay, now if I add, you see here that we have the Gaussian distribution, and this is the top diameter and the bottom diameter. It's better to look at it from the side view, and this would be our heat source. Okay, now let's select the collectors. Here it should be heat, and from cooling we can select cooling, heat. The end time would be 14. And add. So this is selected as well. Now it's time to select the clamping condition. So we have UXYZ, it should be rigid, all, and add. The next one is UZX, and we only select Z and X. The last one is UZ. It should be only clamped in Z. So the clamping, by holding shift, we can select them all. And this should be 14 seconds. Enter and add. We don't need this one. We don't need this one as well. We uncheck the mechanical and we generate input file. We save the model by selecting Ctrl S and we can solve it. So this is the laser VDB, thermal metallurgical, compute, okay. And if it turns green, it means the job is completed. Now the job is completed and it's time to go to see the results in the visual viewer. Now let's go and look at the results. Okay, we open the file here in this one. This should be the required file. Open it and we have to select this contour, node results, temperature node. And by clicking this one, we select the melting temperature of this material. And let's make it a little bit realistic here. And we select and play for this one. As you see, this is the laser spot with a diameter of 2. So the laser spot diameter is 2 mm, and it goes and the process is completed. So we can have it here. We rotate it to see, and we have the full penetration here, which means the process parameters were selected in a correct way. But you can go ahead and try different welding speeds and powers to see the effect of the welding parameters on weld pool width or depth. And that's it. Thanks for watching. If you enjoyed this video, give a thumbs up and hit the subscribe button and check out the video on the screen before it ends. Stay tuned.